You may have thought Tesla had reached the pinnacle of performance, longevity, and low-maintenance design, but hold on to your seats because they're about to kick it up a notch. Elon Musk has unveiled their newest engine, and it's already causing a stir in the industry. Say hello to the hairpin motor, the revolutionary drive unit that makes electric vehicles more competitive not only with previous generations of electric vehicles, but also with internal combustion engines. We're talking about a motor that promises to change the game forever, and we're here to show you why. Fasten your seatbelts and get ready for the ride. We'll dive deep into the benefits of the hairpin engine and why it's getting everyone talking. When it comes to Tesla, there is no denying that they have their haters and their lovers. But one thing we can all agree on is that they are making serious strides in the world of electric vehicles. With a mission to reduce costs and improve the environment, they use software to model the best configuration and employ a unique design that involves welding without the use of rare earth minerals. Their result is a drivetrain consisting of a $1,000 motor and a $5,000 battery pack, making mass-market vehicles not only viable but also highly profitable. But even more exciting are the new engine technologies known as hairpin motors. They are unlike anything we've seen before and are more compact, lighter, and more advanced in every way. One of the most impressive features of this motor is the hairpin motor fill factor. Essentially, this means that the motor has a fill factor of 0.7 compared to the 0.20 found in traditional round wires. This results in better thermal performance and allows for a highly automated production process. The new inverter design is a game changer. It is much more compact, featuring a cast-in-place high-voltage connector and a data connector. You can see this for yourself when you remove the cast cover. Tesla has also optimized the layout of the motor and improved the cooler assembly. They used a friction stir welded part to put it together, and the result is quite impressive. Now, you might be wondering about the filter on the motor. It's no longer a rotatable or user-replaceable part, but that's because it doesn't need to be replaced for the life of the vehicle. Unlike an internal combustion engine, this filter only exists to stop minor wear and production residues, so it never needs to be replaced. Now, let's step back a bit and talk about the basics of electric motors. In electric vehicles, the electricity provided by the battery is converted into motion to move the wheels. Tesla's new motors elevate this process to a whole new level. This is done by creating opposing magnetic fields in the stator and rotor. The push and pull between these fields is what makes the rotor spin. In the stator, the magnetic field is generated by electricity passing through the copper windings. However, in the rotor, there are two different ways of generating the magnetic force. In permanent magnet motors, the magnets in the rotor create a permanent magnetic field. In induction motors, the rotor's magnetic field is induced using aluminum or copper rods. Since these rods are in the magnetic field of the stator, an electric current is induced in them, creating the magnetic field of the rotor. Now that we've covered the basics, did you know that Tesla has been designing its own drive units since day one? When Tesla launched the Model S in 2012, it completely revolutionized the electric motor industry by bringing the drive unit in-house. This meant no more technology licenses from third parties. And let me tell you, their induction and permanent magnet motors are two of the most advanced and efficient electric motors on the market today. The induction motor was first developed by the legendary Nikola Tesla in the 1880s and remains one of the most widely used electric motors today. This motor uses a series of electromagnets to create a rotating magnetic field, which in turn induces an electric current in the rotor to produce motion. Pretty cool, right? Tesla's permanent magnet motor is used in rear-wheel drive setups, while dual-motor versions of the car add an induction motor to the front wheels. Tesla can alternate power between these two motors to optimize efficiency and torque in various driving scenarios. In simple terms, the induction motor is perfect for height work situations like acceleration or hill climbing, while the permanent magnet motor excels in efficiency, especially when cruising at highway speeds. But Tesla has also developed a new type of motor for Plaid vehicles, including the Model S and Model X Plaid, as well as the Tesla Semi. The rectangular shape of hairpin motors provides a better fill factor, meaning the copper winding makes better use of the space and provides approximately 20% more efficiency. This technology offers several benefits. The improved fill factor creates a stronger magnetic field, allowing the rotor to rotate with greater force, resulting in more torque at the wheels. Because the stator can be smaller, energy losses are minimal as the electric current passes through the copper. This optimized winding path simplifies the assembly process, and hairpin motors have a lower risk of long-term failure. But that's not all. Hairpin motors can carry more current than round wires, generating less heat in the winding and motor. This simplifies temperature management and increases the reliability and lifespan of the motor. Additionally, the symmetrical and robust shape of hairpin motors makes them easier to wind than round wires. They don't even need stator bonding like round wires, further simplifying the assembly process. With this innovation, Tesla has raised the bar in the world of electric motors. The design of hairpin motors offers numerous advantages over traditional round wire motors, such as precise positioning and a cleaner design. That's why companies such as Volkswagen, BMW, and General Motors have already embraced this new trend. However, implementing hairpin technology is not without its challenges. One of the biggest hurdles is ensuring the accuracy of the process of bending and welding the copper parts, as even a small error can cause electrical losses. But Tesla's proprietary software revolutionized the game by modeling and simulating the entire motor along with the rotating electric field, allowing them to quickly iterate millions of designs to choose the best one. But what really sets Tesla apart is its commitment to sustainability. They recently announced that rare earth metals will not be used in the next generation engine, which caused quite a stir in the industry. These rare metals are key components of the engine and cost over $100 per kilogram. By eliminating the need for them, Tesla could save hundreds of millions or even billions of dollars in the long run while reducing the environmental and social impact of mining and sourcing these materials. If you are wondering if this will affect the performance of the engine, the answer is no. In fact, Tesla claims that these new engines will have even higher efficiency and lower costs. This announcement has already caused some tremors in the market, with rare earth mining stocks taking a hit after Tesla's announcement. But at the end of the day, the biggest benefit for Tesla is that they will be able to scale production much faster without worrying about the supply of rare materials. This is a win-win situation for both Tesla and the environment. Now let's talk about the weight of the engine. The whole thing weighs 88 kilograms, which is not too bad considering the power it packs. Speaking of power, this new unit is actually an evolution of the previous drive unit released by Tesla in 2017 for the Model 3. What sets this new design apart is the all-new inverter, which is much more compact than before and features a completely new heatsink arrangement. While the overall layout is the same, it has been optimized in many areas to streamline production and perhaps even extend its lifespan. However, there is a potential downside to this new design. The cartridge oil filter is no longer user-serviceable. But fear not, because the filter is designed to last the lifetime of the vehicle. A clever update in this new design is the ventilation hole, which has been moved to the top of the body. This means that if water gets into the drive unit, it cannot get into the transmission unless it passes over the vent. So, what do you think about Tesla's new engine? Don't forget to share your opinions in the comments section.